Dilation. And what is that? Yeah, you can see Marvin the Martian. I don't know if we've said on that. That was me, by the way. My favourite cartoon character is Marvin the Martian. I actually was thinking about taking a funny little picture of me and having me suddenly twice as wide, 3 times as wide, or half as wide, and all that sort of stuff. And I was having too much trouble with it. And I went, Marvin! I look like Marvin, except I'm not black. But yeah, I do have black heritage though. I have multiple black heritage.
Close enough.
Close enough. He's really black. So there's me about 3 months ago. That's me now. Isn't that wonderful? And that's me if I keep eating chocolates and doing all the wrong things and stop riding my push bike. Okay, let's have a look. What's the rule? Outsides are vertical. And you go, wait a minute, what about this one? If I go 2x squared, this is where it gets really confusing. I could say this there, this is twice as tall. Was it a vertical effect? If it made it twice as tall? You get this parabola. And we talked about there, and we talked about 1, 1, and we got that going there. When I double everything, what happens to it? That 1 becomes a 2, and that 1 becomes a 2. So what does it really do, the whole question? Well, that was a bit rough. That 1 becomes a 2. And people think about it makes it skinnier. Well, that's okay. When it comes to a parabola, that's a shocker. So there's y equals x 2x squared. Did it have a vertical effect or does it have a horizontal effect? Bit confusing, isn't it? So that, what 2 means that way is to stretch it out vertically twice as far. So what would it mean if I had y equals a third of x squared? Yeah, and people think of y and everything. This is where parabolas aren't as good as it all. So instead of going through at 1, 1, I'm going to go through here at a third. But what's it actually done? It's brought it down from there, down to there. So it's widened the parabola out that way. So what's it done? How do we put it into words? This one is? Cam, come back to me. Look at the words. Why do people get the words right? It dilates by a factor of 2. Which way? Outsides are vertical. Oh, outsides are vertical. Dilates by a factor of 2 vertically. Yeah? Takes it and makes it twice as tall. This one here is dilates by a factor. Look at the words, okay guys, 1/3 vertical. Now the obvious and most annoying one of the lot. That was vertical, so now we need to do dilating horizontally. I feel like jumping to square roots maybe. Would that work better? Maybe. Let's do this again. It's annoying. If we had y equals x squared, and I turn that into y equals bracket 3x squared. So is a 3 on the outside or on the inside? It's on the inside. Insides are horizontal. Big one, guys. This is where people muck up. Insides do the opposite. What do I mean by do the opposite? So is that going to make me 3 times taller than me? Is it going to make me 3 times wider or 3 times skinnier? Common sense if you think of 3 times by 3, it's going to go 3 times wider, but it doesn't. Insides do the opposite of what you expected. What does it do? Makes it 3 times skinnier. So here we go. What have we got? Dilates. And we can muck around for that for ages. I can believe it, not do it. By a factor of 1/3. Not 3, not 3, not 3. Which way? Outside's are vertical, inside's are horizontal. So late's by a factor of 1/3 horizontally. Now, some people like to say parallel to, which axis? Is that parallel to the x